Welcome back guys. So now today I will discuss the Leetcode weekly contest 282. So now let's discuss the first question of the contest. And also you might see the code of the question might vary because as you will be seeing the video after the contest. Okay. So now I'll explain the question. You are given an array of strings which is words and also another string you are given which is a prefix you can consider. And what you have to do, we have to return the number of strings in words such that uh, they contain pref as its prefix. We have to count those many strings and we have to return that number. Okay, so as you can see in the example, this example, array of string is given and a prefix string is also given 80. And I have to check from each and every word that whether this string has a prefix 80. If this is so, then I'll count that in my answer. So similarly, I have to return 2 because this and this string have a prefix 80, which is given in the question. Okay. Similarly, this also you can see a 0 because code is not a prefix of any of these strings. Okay, so now it is a brute force solution only, as you can see that by the constraints also. In this, we just have to iterate over each and every word, and we have to match the word with our prefix. And if each and every character in the beginning of the word matches, here I am iterating over each and every word, and I am checking from the beginning for each and every word that whether it matches my prefix string or not. My prefix string is S and my array of string is W. I am checking from starting whether each and every character of S is matched by the uh, string or not, a string in the word array. So if it is each and every character is matched, then I'll count it in my answer. As you can see, if k equal to 0, I have defined a variable here, and if k doesn't changes, my answer will be incremented. Okay. And when I'm changing k, when a particular character at a particular position does not match the prefix string and the string that we are considering to match the prefix. Okay. So in that case, I'll make my k 1 and then I'll break. If k equal to 0, which means the prefix matched the strings prefix. Okay. So then I counted it in my answer. So this is how I have calculated the answer and I have returned the answer. So now let's see the second question of the contest. Minimum number of steps to make two strings anagram. Okay. This is the name of the question. So now I'll in the question. The question is we are given two strings S and T, and in one step, what we can do is we can append any character to either S or T. Okay, so to any of the string we can add the character, and we have to return the minimum number of steps to make S and T anagrams of each other. What is an anagram? Anagram is a string. Uh, anagram of a string is a string that contains the same characters with a different order. Okay, so these are anagrams. So now let's see this question and how they are done. Now let's first of all now let's see the approach. Yes, the approach is what I'll do. I'll maintain a frequency array A of 26, and in that I will store that how many times each and every character have occurred in my string S. Okay, how many times they have occurred? X times, Y times, Z times. Let's suppose. Similarly, for string S, I'm doing this. For string 3 also, I'll do the same in another array of 26. Then I again, let's suppose these are x1, y1, z1, y2, z2. Similarly, this will go like this. Okay. Now what I will do is like I will iterate over. Like I have maintained the frequency array. First, I will do this task for both the strings. Then what I will do, I will iterate to each and every character and see that whether x1 is greater than x2 or x2 is greater than x1 or both are equal. Okay. So if x1 is greater than x2, which means I have to add a character in string t. Okay, how many times? x1 minus x2. Similarly, if x2 is greater than x1, then x2 minus x1 times I have to add character a to string s. Okay, because what I have to do, I have to basically uh, match the number of A in string S and number of A's in string T, because then only they will become anagram. So in order to match the frequencies of each and every character in both the arrays, I have to do so. So these are the compulsory steps. So I'll add all the steps that I'm making, and and then I will return the answer. Okay. If x1 equal to 0, then no need to add anything. Answer plus equal to 0. Otherwise, answer plus equal to x2 minus x1 or x1 minus x2 according to the equation. Okay. Because we can add to any of the string. So for each and every character, we'll calculate that how many more characters we have to add either to S or either to A. So these would be our steps. Similarly, we'll count for each and every character and we'll add up all the steps and then we'll return the answer. So this is what I have done in my code. Now let's see the code. Yeah, this is code for as I have maintained the frequency array of A and B. As you can see, uh, for string S and string T, I have made the frequency array, and then for each and every character, I have calculated like because we can do, we can also do like this, like x1 minus x2 or x2 minus x1. Rather than doing like this, we can also do like this mod of x2 minus mod means like modulus. Like mod means like if a negative value is there, then it will become positive. That mod I'm saying. Okay, not modulo. So that's why I have taken the positive value by doing apps, and I'm adding the positive value to my answer because that would be added. Because if AI equal to BI, then 0 would be added. If AI greater than BI, then some x1 minus x2 will be added. If BI is greater than AI, then x2 minus x1 should have been added, but this part will give x1 minus x2, which is a negative integer. So after doing negation on that, like again negative, because we are making it positive. So it will again become x2 minus x1 only, things that I explained in my logic. So this is how our answer will contain the total number of steps and we'll return those. Okay, so now the question third, minimum time to complete trips. We are given an array time where time of I denotes the time taken by the ith bus to complete one trip. Okay, and we are also given an integer total trips which denote the number of trips all buses should make in total. Okay, this is a integer that is being given to us. We have to do it. We have to return the minimum time required for all the buses to complete at least these many number of total trips. Okay. Uh, at least these many trips all the buses combined have to do, and we have to return the minimum possible time that we can achieve. Okay, and also like the multiple trips successively can also be done by each bus. And also the next trip can start immediately after completing the current trip, and also each bus operates independently. Okay, so yeah, now I will explain the approach. What I have done here is I have done a binary search here as what is the maximum possible time that can be taken. So that would be like if we only use one bus, and that too with the maximum time. So, and each and every trip is performed by that bus. So we have total number of trips total into that many uh, that many time that much time that that bus takes, and total trips are total. Okay. So this is the maximum possible time. Okay. So what I have done is I have done a binary search on the time, like whether this time uh, can be optimal for performing at least total trips. Okay. So now let's see the approach. So yeah, now let's see the approach. Let t be the time given to us, and we have to return total number of trips that all buses can do combined. This is the question that I am giving to you. Like I am reframing the given question. Okay. For this, what you will do, you will simply iterate over all the buses, and will iterate over all the buses, and then you will let's say answer equal to 0. Then you will add up all the values into like t by time of I, because each bus can perform these many trips in t time. Okay, so for all the buses we have to do, so we'll sum up and we'll say that you will say that yeah, this is the answer that you want. Like these are the total number of trips that all buses can do in time t. Okay, so now let's see. I have done. I have basically applied binary search on this by using this part. Yes. Now, as I told that minimum time would be, let's say, 1 second only, like 1 second to complete all the trips required. That R be the maximum possible time that it can take. That I told you earlier. The question when I was explaining it. Okay, that is maximum into. Okay, so I'm applying binary search. And first, how can I apply a binary search? Because let's suppose uh, you can do at least 3 trips total. I should write at least total trips in, let's suppose, 100 seconds. Then you can also do these at least total trips in 200 seconds. Okay, so if 100 is correct, then 200 is also correct. So all the numbers ahead of this are correct. And so this is why I can apply the binary search, because I can reject a few answers. Because like let's suppose 1 to 1000 in my is in my range, and 500, for 500 I check, can I do total these many total number of trips in 500 seconds? If yes, then the remaining half is rejected. Why? Because if in 500 seconds I can do, then I can definitely do in 600 seconds also. So why to check for them? Because we have to return the minimum value. So what I'll do, I will consider this half part again. So this is how I'm reducing my search space. So it would be efficient because it would be done in log n only. So yeah, I would do the binary search. So this is the intuition for binary search. Okay, so now let's see the code. This is the code only. Like we'll check for each and every time. Like we know the minimum possible time, maximum possible time. We'll take a mid value and we'll check whether in that much time can we perform the trips such that the total number of trips that we made by all the buses combined should be at least the total given trips. Okay, can we do that? If yes, then we'll reduce our search space. If no, then also we'll reduce our search space. Why? Because let's suppose in 500 seconds you cannot complete at least total trips. So what we'll do? We'll reject all these previous values, right? Because if you are not able to do in 500 seconds, then you are not able to do in even in 499 seconds or 400 seconds. Okay, so this is why the left part would be rejected. So this is the basic intuition for binary search. So this is what I have done, and also how our sub problem will become now, like as I formulated previously, as I explained, like let t be the given time to us, return total number of trips that all buses can do combined. You will return answer. Now what I'll do, I will simply check whether answer is greater than equal to the total required trips. Yes, then I will say yes. In t time, we can do uh, the total required trips. Okay. For the binary search, as I told, I have to check whether at 500 second I can do at least total trips or not. So what I'll do at 500 second, I will call this function and I will check how much number of total trips I can do given 500 seconds. Okay, so I'll calculate the answer and then I'll see whether it is greater than equal to my total required trips in the question. If so, then I'll return true, that yes, in 500 seconds I can definitely do at least total trips by all the buses combined. Okay, so this was the intuition. I hope it's clear now. I have repeated it also. Okay, so yeah, this is the code. As you can see, like I have taken L and R, the minimum and the maximum possible answer, and then I'm checking for the mid value whether mid this much time is sufficient to complete total trips for checking. as I told, like answer equal to 0, and for I'm checking like for each and every, like I'm calculating like for each and every bus how many trips this bus would have made, and I'm adding those, and I'm checking whether it is greater than the total required trips. If yes, then I'll return true because at this time it is possible to do so. So I'll return true. So this is how we are reducing our search space and applying binary search, and we are finally reaching to our answer. Answer would be r plus 1. Okay, why? Because the last possible mid, which is correct, would be our answer. So what would be the last possible mid? Which means this condition should be satisfied. And if this condition satisfied, r equal to mid minus 1, which means mid equal to r plus 1. Okay, this is why I'm returning r plus 1 as my answer. Yeah, now let's see the fourth question in the context. Yes, so now let's see the fourth question. The fourth question is minimum time to finish the race. Okay. So we are given a zero index 2D integer array of tires. In this, two integers are given FIRI, and if we are using the same tire, then for x successive lap, then the time that tire would take us to complete the lap would be Fi into Ri into Ri to the power x minus 1. Okay, this would be the time taken by that particular tire if we are using it continuously for the x successive lap. Okay, and also we are given an integer change time, which means the time which would we require to change the tire. Like we can also change the tire, and we can also keep purchase any new tire. Like we can change the tire to any given tire. Also the current tire type also. Okay, and but we have to wait for change time seconds. And also what we are required to do is we are required to do complete these many number of laps. Okay, so now what is the question is like we have to return the minimum time to finish the race. Okay, so these are the constraints that I told you, like these things can happen. This much time would be taken if x successive time you use the tire, and and uh, and also you can change the tire, but you have to wait for change time seconds, and then you can change to any given tire. Okay, this is a question. Now let's see the approach. So let's say if we are given a tire 1. Okay, so till how many lap we can use it? Let's see that. Like it's r equal to 2. Okay. So 4 8 for first lap time it would take 1, f equal to 1. Okay, second lap time it would take would be 2 seconds. Why? Because f into r. Now f into r square, so it would be time taken would be third lap. For third lap 4 seconds. For fourth lap 8 seconds. The total time for completing these 4 laps with this tire is 15. Okay, 15 seconds. Now listen this carefully. Like let's suppose in the 10th lap 10th lap, what time it would be taking to cover that lap would be 2 to the power 9. Okay, that's clear. And now let's suppose my uh, change time, I will call it CT. Okay, CT. So change time, the time that I have to spend to change the tire. Okay, so if my in 10th lap, how much time I am taking? This much seconds I am taking 10th lap. So for the change time, let's suppose the change time is 1000. So change time is 1000. So what best I can do to cover the 10th lap is either I can use the same tire and I can spend 2 to the power 9 seconds, or what I can do is I can change the tire, and how much time I will spend 1000 for changing time plus which tire I can use, the best tire. Like I assume that this is the best tire only because f equal to 1. So we are considering one tire only for now, so it is best only. Okay, so 1000 for waiting time in order to change the tire plus 1 second. So 1000 one time would be taken to cover the 10th lap. These are the two choices, whether I go with the same tire or I can change it to new tire. New and best tire I can change it to. Okay. For 10th lap only I am telling. So these are the choices that I have. 2 to the power 9 is 512 seconds. So what should I do? I should keep this tire. Why? Because for this particular lap, uh, this tire is giving me better results. It is completing the lap in 512 seconds. And if I would have changed the tire and then I would have run with a new tire, then 1001 seconds I would have spent. Be like 1001. Okay, so 1001 seconds I would have spent if I would have changed the tire and waited for that. What should I do? For this particular lap, I should continue using the same tire. Now let's suppose for the 11th lap. How much time would be taken for this 11th lap? The power 10 is equal to 1024 seconds. And what is my timing to change the tire? Then again I can use the best possible tire. So that would be 1000 seconds. I need to wait plus 1 second to cover the lap with the new tire. So 1001 second I would require to cover the 11th lap if I change the tire. And if I don't change the tire, then 1024 seconds be required. So in that case, I should definitely change the tire. So it is clear that if time, current time, let's suppose current time exceeds my change time plus minimum possible tire, minimum possible tire, then using the current tire for that particular lap is not a good choice. It is as clear. Okay. So this was the thing that I was explaining to you. Now let's see a bit of code that you will come to know it better. So this is the minimum value I have set to some arbitrary height, and I have checked which is the minimum time which we can spend to cover the first lap. Okay. Why I'm saying so? Because x equal to 1 in first lap. So x equal to 1 r to the power 1 minus 1 0, which means fi. So this is why I am taking minimum of ti of 0. Okay. So minimum time to cover the first lap. And what is my threshold value? Like threshold value, the value ct plus minimum possible tire time. Okay. This is the threshold value only because any time greater than that, I wouldn't use that. Okay. So any because in the 11th lap, uh, we got a time of 1024 seconds, so we will not be using this same tire for more than 10 successive laps. Okay, for the 11th lap, we'll not use it. Definitely, will not use it because it is no sense to waste time here. Okay, so what we can conclude from this is like if the current time exceeds change time plus minimum possible tire time, then we should not use the tire in that particular lap because we have a better option available. So which means the maximum number of successive time that we can use that tire is is till this previous lap. Okay, which means in 11th lap we cannot use the same tire, which means this tire can be used only till 10 successive times. Anything greater than that would not be helpful because in the 11th lap, we should have changed the tire and then if we would have gone, then it would be a better result. Okay. So this is what I am trying to explain to you. So now let's see the corresponding code here. So yes, like can is that threshold value that I told you, change time plus minimum possible time of a tire. Okay. So for each and every tire, I'll calculate how many successive till how many successive laps we can use this tire. Okay, I will calculate that. And how I'll calculate that? For each and every lap, I'll calculate the time and I'll multiply it by r because uh, for each and every lap it is increasing by r after multiplying r, as you can see. Okay, it is a GP, geometric progression. So okay, so each and every time the time for that lap is increasing by r. So current equal to current to r. So until what number we can do that many successive laps is till the time uh, our time is less than the threshold value. Till that time, we can perform with the tire. Till that time, we can perform with the same tire consecutively. Okay, so this is the part that I told you. Now let's see the main solution part, which is like I have made a DP. As we all know, for one lap, uh, the minimum time would be the minimum value only that we calculated earlier. What would be there for second lap? So for second lap, we can have two choices, like I will explain you. So for second lap, we'll have two choices. Either we can use the same tire till the first, and in the second lap, we can use another tire. Okay, this is the choice that we can have. Or what we can do is till two consecutive laps, we can keep the same tire. Okay, so these are the possible choices. If I want to calculate dp of 2, which means how much minimum time that would take to complete two laps. Okay, so now let's see what would be more beneficial. Now let's see through the code. Like yes, when I was calculating that from a particular tire how much successive laps I can do. So in during that time, I also updated my DPI. How I updated it? I checked whether that this much time is minimum for these particular number of laps or not. If this is so, then I will do so. What I mean so is, like let's suppose DP of like each and every tire would have made two laps within this time. Okay, so for each and every tire, I checked whether the current time, whether this particular tire is producing less time than the earlier that would have taken to complete the J laps. Okay, if this is less than that, then I'll replace that by my value V. Okay, so I think it is a bit confusing, but you can take a moment and think like what I am doing here. I am calculating the current time, total time for this particular tire till J labs have taken place and V time have been elapsed. Okay, so for J labs, this can be a possible candidate for minimum time for the JH lab. So I'm checking whether it is a right candidate or not. So this is how I'm calculating that till how much number that particular tire is maximum, like till how much successive laps that tire can be used, and if it is one of the solution of taking that particular tire. Like let's suppose there is a tire. I'll explain it more by example. Let's suppose that there is a tire f equal to 1, r equal to 5, and another tire is there f equal to 2, r equal to 2. So what I will do first, I will for the first tire 1 5, let's suppose change time is 10 seconds. Okay, so first tire would be how many laps we can cover from the first tire. For first lap 1 second, for second lap 5 seconds, for third lap it would be 25 seconds, but 25 is greater than our threshold value, which is 10 plus f. Minimum is 1. Okay, minimum equal to 1. So here, so 10. So I will not first lap 5 seconds, first lap 1 second, second lap 5 seconds. Okay, so the total time for one lap will be minimum of 1 comma dp of 1. Similarly, for second lap 5 seconds plus the previous one, so dp of 2 would be equal to minimum of 5 plus 1 6 comma dp of 2. Okay, successive tires I have used. So similarly, for the second tire also I will move forward. So dp of 1 equal to minimum of 2 if I have used this tire, and dp of 2 would be, let's suppose this r is 10. This would be 10. Minimum of 11. Okay, nothing I have changed. And dp of 2 would be minimum of, um, for the second time I am for the second time I'm calculating 2 and then 4, 8. So for 2 laps, minimum of 4 plus 2, comma, dp of 2. So for 2 laps, the minimum time I can do is 6 seconds. Why? Because here it was taking 11 seconds, but here now 6 seconds. In 6 seconds, I am able to complete the lap by using the second tire. Okay, so these are the most basic, like what I am calculating is like the base cases, you can say. First, till how much time for if a tire I can use in the most optimal way. So what we can infer from this is, if we are doing 2 laps, then we should use second tire, because overall time it would give us less in comparison if we would have used the first tire. Okay, so for 2 laps, second tire is better. So this is the best case. So for 3 laps also, we would have calculated the best possible case. Let's suppose dp of 3. dp of 3. It will not go to dp of 3. Why? Because it is not following our threshold values. So, but it will go. So dp of 3 equal to 8 plus 4 plus 2, which is 14 seconds, comma, dp of, okay. So this is how we are calculating that how much time a successive tire can be used, and that would be the minimum for that particular number of laps. So this is what this base case means. I hope it is clear. You can again watch the video. I think this part it would help you, because I think I have explained it a number of times, so you might have got confused. You will sit for a second and think wisely. I think it would be clear to you. Okay. So now let's see this part, is the main part, like how I am calculating the dp. So okay, so dp of j, like what I am doing is I'm telling you how I am calculating the dp. How much laps we have to cover? Let's say NL laps we have to do as given in the question. 1, 2, 4, 5, 6. Okay, these many laps we have to cover. So now let's suppose 8 laps. This is 10. So for covering 10 laps, I have to calculate dp of 10 and I have to return that. What can I do is, I can break my journey into two halves, like till dp of, let's say dp of 2 and plus dp of 8, which means minimum time to complete 2 laps plus minimum time to complete 8 laps plus change of tire, because after 2 laps we are changing the tire. Then only we can use dp of 8, because it is when we are starting from 0, like we are not, like basically after 2 we are changing the tire, because if we were not changing the tire, then it would be dp of 8 only plus dp of 2. Why? Because till 8 laps we did not change the tire, but after that we changed the tire. And if we did not change the tire anytime, then in the previous cases we would have reached dp of 10. In which previous cases? These previous cases, and at that time our minimum value would have been set. Okay, if we are not changing the tire, but if we are changing the tire, then we have to see that at which position I am changing the tire. Let's suppose after 3 laps I am changing the tire, so dp of 3, minimum time to cover 3 laps, plus I am changing the tire, changing time, plus minimum time to do the number of laps, do 7 laps, because from now on I have to do 7 laps only. Okay, so dp of 7, and dp of 7 I have already calculated. Okay, because I am moving forwardly, so the previous values I would have calculated. This is how I am calculating my answer. So dp of j equal to minimum dp of j, comma dp of I plus dp of j minus I. Okay, plus changing time. So this is how I have done it. So yeah, thank you very much, guys. I think it might not be clear, so you can write in the comments also, and also you can watch the video again. I think it will definitely click you. Okay, thank you.